About the project, we have used LM393 comparator, Arduino and breadboard. Arduino, the microcontroller board, serves as the central control unit of the circuit. About the LM393 comparator, the integrated IC is used to compare two input voltages. It has two comparators within a single package. In this circuit, it appears that only one comparator is being used. About the connections, LM393 to Arduino, the positive supply of the LM393 is connected to the 5 voltage pin on the Arduino. The negative supply pin of the LM393 is connected to the ground pin on the Arduino. The inverting input of the LM393 is connected to an analog input on the Arduino. The non-inverting input pin of the LM393 is connected to a specific point on the breadboard. About Arduino to breadboard, the 5 volt pin on the Arduino is connected to the positive rail on the breadboard. The ground pin on the Arduino is connected to the negative rail on the breadboard. The digital output pin of the Arduino is connected to a specific point on the breadboard.
Here is a detailed explanation of the C++ code for an Arduino project that uses a sound sensor to measure sound levels and control an LED based on those levels. Code breakdown. Define constants. This line defines a constant named LED pin with a value of 13, which indicates the digital pin on the Arduino board to which the LED is connected. Setup function. Serial.begin 9600 initializes signal communication at a baud rate of 9600. This setup allows the Arduino to send data to the serial monitor, which is useful for debugging and observing real-time data. Pin mode. LED pin output. Configures pin 13 as an output. This is necessary because we want to control the LED by sending signals to this pin. Main loop. Int sensor value reads the analog value from the sound sensor connected to pin A0. The value returned is an integer between 0 to 1023, representing the sensor's voltage output. Float decibel converts the voltage to a decibel level using the formula for sound intensity. The formula assumes 0.6 volt corresponds to 0 decibel. The logarithmic scale is used because decimals are a logarithmic measure of sound intensity. Summary. In essence, the code continuously measures the sound level using an analog sound sensor, converts at reading to decibel value, then uses this value to control an LED. If the sound decibel surpasses 70 decibel, the LED lights up, providing a visual indication of high noise levels.
How the simulation works in the C++ code for an Arduino with a sound sensor. The initialization. When the Arduino starts up, the initialization communication with the serial monitor at 9600 baud, which is crucial for debugging and monitoring data. It also sets up a pin 13 as an output, which will control the LED. Continuous monitoring. The main loop runs continuously. In each cycle, it reads the voltage from the sound sensor connected to analog pin A0. The sensor picks up sound and converts it into an analog voltage signal. Voltage conversion. The analog reading, which ranges from 0 to 1023, is converted into voltage value ranging from 0 to 5 volts. The conversion is crucial because it translates the sensor's output into a form that can be used for further calculations. Decibel calculations. The voltage value is then used to calculate the sound level in decibel. Next we come to display and decision. The decibel level is printed to a serial monitor, allowing you to see real-time sound levels. The program then checks if the sound level exceeds 70 decibels. This threshold can be adjusted based on your needs. Next is LED control. If the decibel level is higher than 70 decibel, the LED control connected to pin 13 is turned on. And the last one is loop display. Display function ensures the loop doesn't run too frequently, providing a brief pause of 100 milliseconds between readings. In summary, this code sets up a system to monitor sound level using a sensor. Display those levels and visually indicates when the sound exceeds a certain threshold using an LED. It's a simple yet effective way to visualize sound intensity in real time. Thank you.